Good morning, Math 10. It may be morning or afternoon for you. All right, so here we are. We're starting chapter 6 today, and the first one we're going to look at is, of course, going to be 6.1. And this is referred to as being, we're going to be talking about the slope-intercept form of a line. Now, just going to stop here for a moment. Now, I want you to think, what do we need to know to be able to sketch a line? What sort of information would you have to know? Well, what if you were simply given 2 points? Okay, would you be able to sketch a line through 2 points? That would be the minimum amount of information. So if you were given the point 0, 3, say, and the point 5, 8, you could go through and plot those 2 points there. There's 0, 3, and 0, 3 right there, and you've got 5, 8, which would be up here. And guess what? You'd be able to go through and simply sketch the line through those points, wouldn't you? So that would be one way that you could go through and sketch the equation of a line. What other things could you be told that to be able to go through and sketch a line? What if you were told something like this? If you were given the point 0, 3 this time, and you were told that the slope of the line was equal to, say, 2. Okay. Is that something you'd be able to go through and sketch? Well, I think so, because what we could do there is, I'll just erase this, all right, we could go through and say, well, okay, passes through the point 0, 3, and it's got a slope of 2. Now, remember what slope is. Slope is rise over run. And of course, a slope of 2 is the same as 2 over 1, isn't it? So what we could do is we could begin at this point, and we could rise 2 units going upwards, and we could run 1 to the right. So what I've done there is I've gone up 2 units from my point 0, 3, and I've gone 1 unit to the right. All right. So that gives me another point. Now I could sketch in another point starting at this point here. I could also rise up 2, 1 to the right, couldn't I? Rise up 2 and then 1 to the right, and then I can take my ruler and sketch a line through those 2 points there. Now what we're doing today is we're going through and using this, in this particular case, using this fact here. Okay, it passes through a particular point. In this case, it happened to be the y-intercept. So if we know what the intercept on the y-axis is, and we know what the slope is, we're going to be able to sketch the line. We're also going to be able to come up with the equation of the line. So back over here, I want us to start by looking at this here. All right, so let's have a look at this. To sketch a line, we need to know at least 2 things. What do we need to know? Well, okay, one possibility is if we're given the slope, okay, which we usually abbreviate with an M, and a single point, say the intercept on the y-axis, which is B. Okay, so let's go through. I want you to see if you can go through. We'll pause the video here, take a moment, and I want you to see if you can do A and B, which is the first one is a slope of 2 and a y-intercept of -3, and then you've got a slope of -1/2. Now remember, negative slopes go downhill as we go from the left to the right. So I want you to pause the video and see if you can come up with that. So I've done the first one here, A. So you can see here I've got a y-intercept which is -3. Okay, that's where it passes through the vertical axis, the y-axis. And you can see here I've risen up 2, 1 across, 2 up, 1 across like that. And that's given us our line. Okay, just like that. Okay, right, let's pause again and go through and do the second one here. And there's our second line. So I went through first of all and I located the y-intercept, which was 2 there on my line there like that. Now I want you to think of what a slope of -1/2 is. So I've got a rise over run. So I can think of it like this. So I can think of my rise is -1, so I'm dropping down 1 unit, and my run is 2. That takes me to that point there. Alternatively, I could think of rising up 1 and going back 2, and that gives me another point, doesn't it? Okay, so what's our next step here? The next step that we're going to be thinking about here is we want to come up with equations. Okay, so the next step is to write the equation of a line given that we know what its slope is m and its y-intercept are. Okay, so to write the equation of a straight line, we can use the following two constants. Okay, so we've got the letter m, which is the slope, and guess what? We're going to come up with this new this new constant, which is the y-intercept, and that is b. Okay, so it crosses through, the point that it crosses through is 0b. So it turns out if we know what the slope of a line is, m, and we know, so that's the slope, and we know what the y-intercept is, and we're going to call that b, the slope, the equation that we can use to write the line is y is equal to m times x, so slope times x, that's the rise over run, or the rate of change, and then we've got plus b there like that. And that's referred to as being the slope-intercept form of the line, and that's something you're going to be remembering for the rest of your math career. So on page 2 here, all right, we want to go through and look at these examples here. So what we have here is, okay, we have a table of values for our first example. We have a graph. We want to find the slope. We want to find the y-intercept, and we want to find the equation. So let's go through and do the first one together. So I want us to look at our table of values here, all right, and let's see if we can determine what the slope is. Now, what I am going to do is I'm going to go through and I'm just going to expand my view here so that I see it a little bit better. So, well, first of all, I can write down what my y-intercept is. My intercept on the y-axis is 1, isn't it? Now, can you see what the slope is? It looks as though the slope, if we take 2 points on the line, okay, it looks as though if we look what's happening to our y values here, okay, our y values are increasing by plus 2 each time, isn't it? Which tells us our slope is equal to 2. So we could read it from the table, or we could read it from the graph, so rising up 2 and 1 across. So that's a slope which is 2 over 1, 2 over 1, which is just the same as 2. So we can write here for the equation, the equation is going to be m times x, so it's 2 times x, all right, there's 2x, and then it's plus the y-intercept, so it's plus the y-intercept, and I should have written, right there, I should have written plus 1. So we've got y is equal to 2x plus 1. We're going to pause, and I'd like you to go through and check out. So here's our second example here. First of all, I noted our slope was equal, our y-intercept was -1, and our slope was equal to 1/2. Okay, so it was 1 up and 2 across, wasn't it? You can see it from the table. As we go from -1 to 0, we're increasing by 1/2 each time, isn't it? So there's our equation. Y is equal to 1/2 x minus 1, or you could view it like that. Right, what's our next one here? Well, once again, reading off the y-intercept, b is equal to 4. Now look at our slope here. Our slope was, or is, our slope is, if we imagine going up 2 and it's back 2, isn't it? So that's a slope which is going to be, it's negative. It's -1 over 1, or just simply equal to -1. So we get y is equal to -1 times x. Highlight it here, -1 times x plus 4. Now, that -1 times x, we could just write as -x, couldn't we? All right, so y is equal to -x plus 4. All right, let's have a look at the next one here. Okay, so first of all, I went through and I've determined what my y-intercept was. It was -3. And looking at our slope here, I went up 2. It's a negative number for the slope because it's running downhill. Okay, and 1 to the left, so it's -2 over 1, which is -2. So that's what we get there, isn't it? Okay, there's our m. Okay, so that goes there, -2 times x, and then I've got plus -3, which I could write as -3. Okay, so let's continue on here, onto the next page. Okay, Now what I want you to do is pause the video, and I want you to take a moment to go through, and if you haven't done this already, this is a really good app to have on your phone or tablet. All right, now, if you're working on a laptop or a computer, you can simply put Desmos, just type in Desmos into your web browser, into Google search, and open it up into your web browser, into the browser, okay? And then you don't need the application, okay? Now, I'm going to show you this, and I'm going to do it in my browser and show you what you can see here, because it actually works really nicely. So here I am on my web browser, and I simply typed in y is equal to mx plus b, just simply by typing it in. Now, m is a variable, it changes, doesn't it? It's a parameter, okay? B is also something that can change. So we can add a slider here, right, for m, and we can add a slider for a. Now, if I go through, I can change my value of b. So if I start here and I put b is equal to -1, I can go through and I can change my slope. So I can make it a positive slope or a negative slope. So if I do this one here, you can see here, all right, my value of b is -1, which tells me my y-intercept is -1, where my pointer is, and m is equal to 1. I can slide along and change the slope to 2, and my y-intercept is still -1 here, and I've got a slope which is 2. Okay, I can increase it to 3. Now I can do a negative slope as well. Right, there's a slope of -1. Now if I change b, I can increase or change the value of my y-intercept. So here I have a y-intercept b which is equal to 5. You can see that's where it crosses there, and the slope is equal to -1. So then I can change the slope from there as well, negative slope to positive slope. All right, so that's something that you can Desmos, and if you have it on your if you have it on your phone, or just simply open it up in the computer, it actually works really nicely. Right, let's get back over here. All right, so you can try that. Now, here's our first example here. We want to go through and we want to write the equation of a line in slope-intercept form, okay? And then we're going to check it using technology. Well, so let's do A first of all. So what we have here is we're going to, first of all, is I'm going to determine what my value of B is. So this is for A. All right, so B is my y-intercept, and you can see here, I look at that, my y-intercept is equal to 1. Now, what's our slope here? Well, to find slope, remember, from last chapter, we've got to find a couple of nice points, okay? So I'm finding a couple of points which have nice whole number or integer number coordinates. Now, so if we look at this here, right, if I imagine, I know that I'm going to have a negative slope, so I can rise up 2 and I can run 3 to the left. All right, so my rise here, my rise is, okay, if I write rise over run, okay. All right, my rise over run is, I've got a rise which is 2 and I've got a run which is 3, and I'm going to make it negative there like that. Now, so y is equal to mx plus b. All right, so we're going to have -2 over 3. That's my value of m, okay, times x. And then we've got plus 1. All right. Now I'm going to go through and I'm going to check that on Desmos. Okay, so I'm going to simply go through and delete those there. And I'm going to put in here, so I've got y. I'm going to type y is equal to -2 divided by 3x. And what was my y-intercept again? My y-intercept was plus 1. And that sure looks like the graph that we had there before, doesn't it? Okay, so if I just go through and I copy that out of there and I come over here, does that look as though like the graph that we've got in the example there? It sure does, doesn't it? There's our y-intercept. All right, so that was pretty good. So technology is kind of... So for example number 2, you've got 4 lines I'd like you to try to go through and sketch here. All right, so let's take the first one and then we'll pause and let you have a go here. All right, so our first one here, A, I've got a y-intercept which is -2. So what does that mean? you're going to go through, you're going to take your pencil and you're going to locate a y-intercept which is -2. Then we've got a slope. You can see that the slope there is equal to 3/4. All right, so what does that mean? It means that if I take my ruler, okay, I'm going to rise 3 units up and I'm going to go 4 to the right. And that gives me a second point, all right there like that. And then I can take my ruler and I can simply put the line that runs through those points, okay, just like that. Okay. Right, so why don't you have a look at the next example and see what you can come up with. So for example number B here, what do we notice? We notice that we don't have a value of B, don't we? So if there's nothing added on, you can think of it as being +0. So that tells us our y-intercept is equal to 0. And we've got a slope which is, so we can write here B is equal to 0, okay, and M is equal to -3/1. So I've located it there in green. So what I'm going to do is I'm going to go through and I'm going to, from 0, I'm going to rise up 3 units. Now, because it's a negative slope, I'm going to go to the left for my run. And so that tells us that we're running through this point here. Okay, and then we can take our ruler and we can sketch it through there like that. Okay. Right. Pause the video and let's have a look at C. Okay. So I noticed that my y-intercept is 4, so I located the point 4, and I've got a slope which is -1/2. So I rose up 1, and then because it's a negative slope again, I went to the left 2 units. And I marked that point there. Then we can take our ruler, and we can simply sketch through there like that. And there we go. There it is there. Right, for the last one there for D, what do you notice? We've got y is equal to, we don't have anything with x, so would that be just y is equal to 0 times x plus 6? So guess what? We've got a slope which is m equals 0. Now I want you to remember back to chapter 5. What's a slope of 0? A slope of 0 is a horizontal line, isn't it? So what we've got here is we've got our graph in this particular case. It's got a y-intercept which is 6, and it's got a slope of 0, which is simply going to be a horizontal line running through y is equal to 6. Sometimes a function like y equals 6 with a slope of 0, sometimes that's called a constant function, because it doesn't matter what the x value is, y is a constant 6. Okay, so that's a horizontal line. Right, let's buzz over and have a look at the next example, which is example number 3. All right, so here we want to go through and we want to model, okay, and solve a problem using an equation in slope-intercept form. Submarines must withstand tremendous pressure on all sides from the water. The table shows the linear relationship between pressure and water depth. Now, in your science, you may have gone through and figured out the units for pressure. So at a depth of 0 meters, that's on the surface of the Earth, air pressure is about 100 kilopascals. Now, if you're filling up tires with air, 100 kilopascals is about the same as 15 psi, approximately. All right, now, you can see what happens here. As we increase to a depth of 25 meters, right, which is roughly about 80 feet, look what happens to the pressure. The pressure goes from 100 to 350. In other words, it's 3.5 times atmospheric pressure. You can dive to that sort of depth, but you've got to be super careful. Then we go to 50, and you can see here our pressure is increased to 600. We go to 75 meters. Our pressure is equal to 850. So at 75 meters, all right, which is kind of about 3/4 of the length of the football field, the pressure, the water pressure, is about 8.5 times what the air pressure is. Okay, so submarines can't go that deep. They've got to be extremely strongly built. Now, what I want you to do is pause the video and I'd like you to go through and plot these points on the graph. So we've got depth on the horizontal axis, and we've got pressure on the vertical axis. Right, so I went through, I plotted my points, okay, and I got a line which looks like this. Okay, so I plotted B is equal to 100, okay, and I also, so that's my y-intercept. I took some points from the table, okay, the difference in the y values, so I did 100 minus 350 minus 100, and then I did my difference in the x values of 25, and that gave me a a slope which is 10 kilopascals per meter. All right. So, what does the slope represent? Well, the slope here is 10. So slope represents, so what we can write here is, we can say here pressure, we can say that pressure increases, and I spelled pressure wrong, increases, having trouble with my pen, at the rate of 10 kPa per 1 meter of depth. Now, B. So what was B equal to? B is equal to 100. And it's kPa. And so what's that? That's the pressure, okay, at D is equal to 0, right, or at the surface, isn't it? Okay, all right. Okay, so writing the equation. Now, the equation is y is equal to 10 times x plus 100, isn't it? Okay. Now, if we use what we have there, so P is what our y is, okay, and we've got 10 times d, the depth in meters, plus 100 like that, don't we? Okay. So it says there, let's have a look at the next part here. It says, let's highlight some things here. The deepest point on Earth is Challenger Deep in the Mariana Trench. This trench is located in the Pacific Ocean. In 1960, okay, the Trieste reached the bottom of the Challenger Deep. At this depth, the walls protecting the crew members had to withstand a pressure of 109,000 kPa. What is the approximate depth of Challenger Deep? Well, what we're going to do here is we're going to have to solve a little equation, aren't we? So if we go through and we plug in, we substitute in 109, 300, okay, so that's what our value of P is equal to 10 times D plus 100. Now what are we going to do? We're going to go through and we're going to subtract, we're going to subtract 100 from both sides. So that's the first thing to do. So that's going to leave us with 109, 200 is equal to 10 times D. So all I did there was subtract 100 from both sides. So minus 100, minus 100. Hardly changed the value on the left, didn't it? Okay, and then we're going to divide by 10, so D is equal to, if we take this number and divide by 10, we're going to have 10920, and that's meters. Now, what's that in kilometers? That's equal to 10.92 kilometers, okay? That is deep, okay? Right, so let's look at our last one here. All right, Student Council rents a portable dunk tank, okay, as a fundraising activity. Students must pay for the chance to hit a target. All right, you all know what dunk tanks are there. Okay, so the relationship, let's have a look at this. We've got given an equation here, but it's in a different form that we've seen before. The relationship between the number of balls thrown X and the profit Y in dollars may be represented by this equation here. So X is the number of balls, and Y is the profit. rewrite the equation in slope-intercept form. So I'm going to take up a little bit more space for this. I'm going to come down here. So I've got a bit more space. I've got 3x minus 2y minus 600 is equal to 0. Now what I want to do is I want to write it as y equals. So what I'll do here first of all is I'm going to take the 2y and I'm going to put it on the other side because it's already minus here. So I'm going to add 2y here and I'm going to add 2y here. So that gives me 3x minus 2y plus 2y is 0 minus 600 is equal to 2y. Now, flipping the left hand and the right hand sides, I can actually put the 2y first is equal to 3x minus 600. Now, how do I get from 2y to y? What do we need to do here? We need to divide by 2, divide by 2, divide by 2. So every term gets divided by 2. Y is equal to 3 divided by 2x minus, now we've got 600 divided by 2, so that's going to be minus 300. Okay, so what's this again? So y represented the profit and x represented the number of balls that were being thrown, wasn't it? So I'll just put a little number symbol there like that. Okay, all right. So let's have a look here. State what the slope of the line represents. Okay, so 3 over 2x is the profit. Okay, so m is equal to 3 over 2. Now, I think what we can assume here is, okay, what are people? People are paying, it looks as though they're paying 3 over $2. So 3 over 2, or a bigger pardon, is equal to 1.5, isn't it? Okay, so the profit is, so what we can say here is that for every ball thrown, okay, $1.50 is earned. Okay, now that may not be all straight profit because what we do have here is, of course, we had the minus 300, didn't we? So it looks as though that would represent, the minus 300 would represent the cost of actually renting the tank. Identify the y-intercept. Well, the y-intercept is b is equal to negative 300. Okay, so this represents what? Okay, before any balls are thrown. Okay, before any balls are thrown. Okay, that's when x is equal to 0. All right, the profit is negative $300. Okay, so that would indicate to me that just the cost of getting the tank delivered and the cost of renting it is $300. All right, so you have a negative profit, all right, before you even start throwing balls. Okay, right, the break-even point is the point at which the money raised, all right, is equal to the money spent. How many balls must the student sell to reach the break-even point? Now, what was our equation again? Our equation was P for profit, 3 over 2 times X is the number of balls, we'll write that, and it was minus 300. Now, the break-even point is going to be when P is equal to 0, isn't it? So this is basically, we're coming in and we're making P is equal to 0. So if we solve this a little equation, we're going to go through first of all, and we're going to add 300 to both sides. Okay, so 3 divided by 2x is equal to, and that should be a positive 300 there. Now, what's the next thing we need to do there? To solve for x, we're going to do two things. Okay, we're multiplying by 3 and we're dividing by 2. So if we multiply by 2 on both sides, we're going to cancel out the 2's on the left. And if we divide by 3 and divide by 3, this is what happens, isn't it? We get 2 divided by 2 is 1. 3 divided by 3 is that, isn't it? So that leaves us with a single x. So basically what we did here is, all right, to remove the 3 over 2, we had to multiply by 2 over 3, which is the reciprocal. So we've got x is equal to 300 times 2. That's what we have on top. And then we're dividing by 3. So that's equal to 600 divided by 3, which is equal to 200. All right, so that would be, okay, we have to have 200 balls thrown, okay, before we start. And of course, they're charging. The slope, of course, was equal to 3/2 or 1.5. It looks as though they're charging $1.50 per ball. Okay, so they're going to have to sell a lot of balls to be able to break even there. Right, so, okay, this is where we go through. I'd like you to try some of the exercises. This is the exercises from the book. If you don't have your book at home, there's a PDF version, okay, put onto our Scalander site. And there's also a worksheet for you to work through, okay? So good luck with that.